Hello, everyone, and welcome to our presentation. My name is Janine Donnelly. I am the Manager of Webinars for IBM Systems Magazine, and I will be the moderator for today's event. Today's webinar, New World, New Digital Demands, Is Your Mainframe Infrastructure Ready?, is sponsored by BMC Software. Our featured speaker today is Jay Lipovich. Jay is Principal Product Manager for Mainframe Solutions Optimization at BMC. Jay has responsibility for systems management and MLC cost management solutions at BMC. Who could have expected the explosion of the digital economy, one where consumers demand lightning-fast, personalized services anywhere and anytime? This demand has resulted in highly disruptive workloads that have increased transaction levels that no longer follow the old traffic rules, creating peak transaction times when you least expect them. Today, BMC mainframe expert Jay Lipovich will discuss how you can manage these highly disruptive workloads, all while reducing costs. With our introduction complete, Jay, I will turn the presentation over to you.
Thank you, Janine, and good morning, good afternoon, good evening for those of you joining us. It's a pleasure to have you with us, and we hope that the time you spend here will be useful to you and to the organizations that you work for. As Janine mentioned, there's a lot going on in the world of digital, and a lot of it's impacting mainframes. And so what we wanted to do was spend some time discussing those impacts and how those impacts affect the way we manage the mainframe infrastructure. So some of the topics we'd like to discuss is just how does this transformation change the mainframe? How does it change the way we manage the mainframe infrastructure? And then what has BMC done with the MainView product suites that enable customers to manage this transformation and support digital workloads in the way that, quite honestly, the mainframes become known for. So we'll talk about some details of that, and then, as was mentioned, we'll have a Q&A session at the end, and if you have a question during the discussion, please submit that, and we'll be able to cover, we'll cover as many as we have time for when we get to the end of the session. One of the things that we've done at BMC for a little over 10 years now is to survey the mainframe market and try to understand what customers are dealing with and what they need help with. So in the survey that was done last year, that some of you may be familiar with, we asked what kind of issues they were dealing with, and in particular, in the question of better alignment of the business with IT. And in that case, we asked, what are your top issues? And as you can see, nearly half, and by a large margin, the number one concern was how to react to business requests more quickly. So if you think about what that means, on the application development side, it means they're being asked to do faster development and to be more agile in the development. And they're being asked to deliver a combination of new functionality to existing applications and new applications. And one of the interesting things that customers say they're learning is that if they have existing business applications, let's say application 1 and application 2 that do a certain function, when they integrate 1 and 2, the 1 plus 1 becomes 3 or 4 or 5 in terms of value to the customer and the ability to drive more business for the organization. Now, one of the effects of this type of activity is some organizations find they've got less test time. So more new applications, more application changes rolling out into the infrastructure, and that means there could be performance impacts that may not have been anticipated. So as we asked some more questions, we asked about how are customers dealing with application modernization and what's important. And what you'll note from this, the first concern is how to modernize the existing applications to take advantage of new technology. Then they start to deal with how do we deliver more functionality, how do we integrate applications, and how do we make applications both web accessible and mobile accessible. And when asked about mobility and the mainframe, the same type of concerns were raised and the same types of directions are seen, making existing applications mobile accessible and then developing new mobile apps, and not surprisingly, the concern for security. How do you secure the corporate data that's going to be floating around on various mobile platforms? And it appears that now that organizations are embracing digital and it's the ability of the mainframe to support it really effectively, they've realized there are a couple of other questions that are going to raise concerns for them. And one is the performance and availability requirements. The digital world and the digital customer has a different expectation. We all do. We pick up our smartphone or our tablet, we tap it, and we expect it to respond. And so customers using those channels to do business with a company expect that kind of response. And so the availability and performance expectations, as Janine mentioned in the opening, the digital engagement paradigm is a customer can engage any way he wants, anytime he wants, and from anywhere that he wants. And along with the availability and performance expectations, the fact that they can engage in so many different ways and at so many different times makes the workloads more unpredictable. And so in the survey, customers responding recognize that these are going to become issues as mobility continues to impact the mainframe. One of the values of the survey is being able to look over time and see the rate of change. And one of the more interesting changes is one that for many people is surprising. So part of the survey asks, what is driving your growth in MIPS? If in fact you're growing MIPS, what's driving that? And from 2013 survey to the 2015 survey, the respondents who said that growth was driven by new applications on the mainframe more than doubled. And for many people, the idea that the mainframe is growing because of new work, there's a perception that, well, that's not the case. Just legacy work is there, and people are taking work off the mainframe. But according to the survey and the respondents in the survey, that's not the case. And incidentally, this survey is responded to by approximately 1,200 people who are mainframe technicians and management and executives. So it's a broad-based number that suggests that the mainframe is doing a little more than what people might have thought. There was an interesting study done by Javelin Research. They did a study on banking and the impact of digital on banking, and you can see some of the results. One of them was that more people choose mobile first for engagement than the number who choose branch banking. But as Javelin found, they said the move to mobile, number one, is happening faster than anybody had expected, and it's profoundly changing banking, not just the applications that are being used, but it's changing the banking business. And we'll talk a little bit more about that with an example of how that can happen and why digital can drive more activity, but there's a question of what's it doing in terms of driving the business. When you think of mobile devices and you think of mobile applications and coding for those, frequently what comes to mind is Java. And the usage of Java on the mainframe, which has been around for a lot of years, has actually become more prominent and more successful in just recent years. So there were some questions in the survey about Java. And it was interesting to see that 93% of the respondents have Java running on the mainframe. About half of them say that it's flat or steady, small amount of growth. And about half of them say that it's growing at more than 10%. So of those who said it was growing at 10% or more, you say, what's driving that growth? 70% say it's driven by new applications written in Java running on the mainframe. And half of them say they're rewriting their existing applications to go to Java. So when we think about the digital activity, it's a combination of more activity to existing applications plus this explosion of new applications, many of which may be driven by the ability to run Java on the mainframe platform. All of this is coming together. It's almost like a perfect storm. The part of the digital engagement that's impacting data is that, you may have seen the numbers, we're doubling the amount of data in the world every 2 years. And maybe more importantly, it's not just structured data. It's not just name, address, birth date, account number. It's images of checks. It's videos. It's signed documents. It's unstructured data that can take up a lot of space and have to be accessed frequently or quickly, and puts pressure on the data management aspect. On the infrastructure, we've got all of this unpredictable activity. We've got a growing volume of activity, and the expectation that I mentioned that the digital customer expects nearly instantaneous response. While at the same time, organizations are always looking for the opportunity to optimize and to reduce costs. And not surprisingly, the top two priorities for IT are optimizing the cost of the mainframe, and close behind, delivering the availability, the 5 nines availability that the mainframe is so well known for. So, you step back and you ask the question, we've been managing the mainframe for 50 years. Don't we know how to do this? Has anything really changed? Won't we be able to just keep doing what we're doing and be successful? And there's a part of us that would think about that and say, sure, why wouldn't that be the case? So then we look at some viewpoints of other interested parties at a much higher level. This data comes from surveys of CIOs. And it was interesting and almost shocking. 63% said they're unaware of performance problems until calls come to the help desk. And 3/4 say they are being pressured to reduce the time to resolve problems. Now, if we think back to the new customer who's a digital channel engagement customer, their expectation of instantaneous response, the CIOs are feeling that as they understand they have to respond to those customers in a different way. When we go back to the Mainframe survey, actually, these results align with some of what the CIOs are telling us. And this was for those who have availability as a top issue, which is a majority of people. What kinds of issues do you have with availability? So elimination of planned outages is an effort we're always working on. That was number 1. And then the rest of them kind of grouped together as all number 2. And it's interesting to see that faster problem resolution, improved automation, and proactive problem notification are on the list. And that's one of those where we'd say, but haven't we been doing that all along with the mainframe? And so the answer seems to be maybe things have to be done a little bit differently. And finally, looking at the CIO data, they say that, 89% of them say the mainframe work is increasing. 87% say that they see new risks to the performance of mainframe applications. And maybe the most interesting one, I should have considered setting up a poll for this. Would be a thought for next time. But I'll ask you to think about how many of you participate in war rooms and how often do you participate? Because according to the CIOs, nearly 80% of them have monthly war rooms. Over half of them have weekly war rooms, and almost 10% of them have daily war rooms. So you can see the concerns that they have that we've got to find a better way to recognize, react to, and resolve problems that doesn't involve calling war rooms with the people and the time involved in that. So we think there are four things that can be identified as driving this change and making CIOs uncomfortable, and those who respond to the survey feel like we still need to do more with infrastructure management for availability. And the four V's are the volatility, the velocity, the volume, and the variability or the variety of the type of work that's being driven on the mainframe. So let's spend a little bit of time understanding how this works. One of the key drivers is unpredictable transaction patterns. So what that looks like is if we look at the legacy engagement patterns, this is a pattern that most mainframers are well familiar with. It had the descriptor of the McDonald's curve in a lot of organizations. You'd have the morning peak, you have the afternoon peak, a drop at lunch. Okay, you had the early morning batch, you had the nighttime batch. We know how it runs. We know what it looks like when it's running well, and we know what it looks like when it's not running well. And that's all driven by the fact that we know what's driving our business and when it happens. Well, with digital engagement, the digital business customer engages whenever he wants to. All the peaks change. All of the knowledge of when those things will happen have changed. It would be interesting to see, for example, if credit card companies are seeing different patterns of authorizations, maybe more in the evenings as people pay with things with their phones. Or are the phone companies seeing different patterns related to smartphones now being payment devices as well as talking devices? So all of these unpredictable patterns make it more challenging to manage the infrastructure in a proactive way. So let's look at an example to understand just how fundamental some of these changes are. And let's consider a traditional interaction with a bank credit card and a bank. So the traditional customer deposits a check at the bank and gets some cash. They may do this at an ATM instead of a branch. And then they go shopping and they buy something with a credit card. They go to dinner, buy dinner with a credit card, go to a movie, probably pay cash for the movie. Okay, so you think about this series of interactions generates a series of transactions unloading on the infrastructure. It also generates revenue for the bank. The deposit provides funds on which the bank can make money. The credit card transactions generate credit card fees. So we've got here what would look like three transactions with the bank and three opportunities to make money. Now, if we consider the digital customer deposits a check with their phone, and then they check their balance. And then they go shopping and they buy merchandise with their phone, and then they check their balance. And then they buy dinner with the phone, and then they check their balance, and they find that they maybe need some more funds. They transfer from a savings account or from mom and dad, if that's the thing they have set up, and then they go buy their movie tickets with their phone. So here we have a whole series of transactions and transactional interactions with the infrastructure that may not drive additional revenue, but certainly drives additional loading on the systems. And it drives them in a way that becomes more unpredictable and with a greater volume and doing different things. When you buy merchandise with a credit card and the traditional interaction, that's all that took place. In the digital interaction, frequently exhibited by millennials, checking the balance is a regular activity. So balance lookup in banking now becomes a type of activity or a type of transaction that occurs more often. So the patterns change, the timing changes, the type of transactions that are executed start to get changed by the digital customer. So the implications for this are actually pretty simple. One, we don't know what we used to know. When you think about it, all of the knowledge we've gained over the last 30, 35, XXX, whatever years about how our systems behave and how the mainframe reacts to changes in those systems, all of what we know may not apply. What we thought were good thresholds to tell us when there's a problem with a CICS application, because that application now is actually handling more transactions at different times and different types of transactions, we may not know what to look for. We may not recognize right away when there's a problem. The other is a business imperative. We have to act faster, intercept, and resolve the problems sooner. You know, when you think about it, an outage of 5 seconds or 10 seconds doesn't seem like that much. And for a customer doing a particular transaction, it may not be that critical. Unless that customer becomes very unhappy at not being able to do the transaction quickly enough and makes that a subject of social sharing. Now, there's a potential for a social impact on the entire business as a result of not delivering the service that the customer expected, even though it might not be terrible service, the service might not be totally down. And there is a bank in the Asia Pacific area that, as part of their monitoring, they're monitoring social sites, just in case something's happening that they haven't caught in all of their other ways. They might be able to see it from a social site and start to react to it before it creates a major problem. So how does MainView help the IT infrastructure group manage what's changing in the digital engagement? So I'll share some of the things. We won't go into detail about all of these capabilities, but we'll share some of the things. One of the first focuses is cost. Since that's the top IT priority for the mainframe, we focus on how to lower the cost of managing and running the mainframe. Because most systems now are so interconnected, the relationship between CICS and DB2 and MQ and the network and maybe Java in the environment makes it very difficult to figure out where's the problem. And so having a way to see all of that across multiple LPARs and multiple systems is a technique for more quickly finding and resolving the problems. But beyond that, there's a need for more analytics to help us learn the things or relearn the things that we used to know that we don't know so much anymore. And we'll talk some more about how we do that. And then we can think about moving to lights out capabilities It's nice to have the system recognize problems and warn us about problems. It's even nicer if our infrastructure management not only recognizes them and warns us, but also takes action and then tells us, hey, we've already taken care of it. You don't have to worry about it. And then what we hear from a lot of IT professionals in the mainframe and what data from other surveys show is that sites are getting larger, and the scope of responsibility for IT professionals is growing. So the number of MIPS per professional or the number of technologies that the IT professional is expected to cover continues to grow. And finally, as the nature, as the makeup of the workforce changes in the mainframe, providing a common, easy-to-use interface that's familiar enables greater productivity and greater resolution of problems more rapidly than what was possible without it. And finally, I want to make a note about customer support. We do customer support satisfaction surveys continuously. BMC does satisfaction surveys across all of its products. Our customer satisfaction survey results show extremely high, world-class levels of satisfaction with the customer support. And we get comments from customers about the level of support, our willingness to help, and in some cases, when the customer contacts us, the problem ends up not to be any kind of a problem with one of our BMC solutions, but it's a technology problem, and our technologists work with them and help them find solutions to a problem that, in some cases, extends beyond just our solutions. So part of making our customers digital ready with MainView is the customer support that we provide and that we've got there underneath what the customer is trying to accomplish. So let's talk about some of the features, some of the capabilities that are necessary and that we've been delivering to help manage the change that's being caused by digital. First is what I'll call the self-learning infrastructure management. So let's go back to our example of the legacy customer and the digital customer. In the legacy customer situation, because we knew the patterns, we knew what was good and what was bad. We knew what was normal, what was a problem. And we could set thresholds to alert us and to trigger automated actions to resolve those problems. Now, we don't know that anymore. The digital pattern, and there really is a pattern, it's just a new pattern, it's more volatile, we have to learn it and figure out what it is. That digital pattern needs to be managed with the threshold approach as well. So within MainView, we structured a capability we call Threshold Advisor. And the concept is very simple. The concept is, if we observe the performance of the systems running with new digital work coming into them, we can learn what's normal and what's not normal. So Threshold Advisor looks at history data, does statistical analysis of it, and determines what's normal, and then can recommend, based on what's normal, here's what would be a good threshold. Because if you hit this threshold, that's starting to be not normal. And because things change over time, Threshold Advisor can continue to make observations and adjust those numbers and provide that information into the alarm and alert functions that are built into MainView, and including things like recognizing that there are different thresholds for different times of the day, for different days of the week, and for different periods of the year, because businesses have seasonality. And this is a way to address the volatility, variability, variety, and volume changes that we see being driven by digital business. Another way to address digital is to take a lot of data and condense it to the point where, at a high level, as in this example, the DB2 Health Navigator, just roll up the data to the level where, tell me if there's a problem. Now, in this case, we've got the 9 areas of focus and the exception status, and clicking on any of those, like one of the yellow ones, would then drill down. There are approximately 80 metrics underneath these 9 that can start to explain what's causing the particular problem. As one of our customers said, the intuitive and powerful interfaces remove complexity, and that's one of the goals that we have in the efforts. And in their case, they said the DB2 staff productivity, they had a measured increase. They said it increased by 60%. Another way that we could address the volatility and what we don't know that we used to know is by automatically detecting things. So Mainview can automatically detect, for example, looping jobs. It can raise an alarm, or you can set it up to automate a response. If you detect a looping job, if it's this kind of job and you see these kinds of conditions, go cancel it. Don't continue to drive up my CPU usage, don't create interference for other work, and don't drive up my costs. In the area of IMS, where in spite of the fact that IMS is not a huge growing technology, it's a critical technology, particularly for banking and for transactional types of systems. And that is probably, according to the survey data we've seen, that is the area where the skills concern is the most acute. So one of the things we were able to deliver in a recent release of Mainview is some automation, so we can automatically identify batch processing regions and that are misbehaving, if you will. So we observe what's going on with the data. We recognize how it's not normal, and then instead of just displaying the data, we can say, these guys are misbehaving, and here's what you could consider doing to make them behave better. So we're trying to get to the point of delivering a solution to the problem and not just the data that indicates the problem. Now, for those customers who have Strobe and who want to identify the inefficiencies in specific application programs, we built an integration in our partnership with CompuWare between Mainview and Strobe. So Mainview can identify the high-consuming job, and typically what happens is you get notified that some job was eating up a lot of the system, but it's a past tense statement. So you got to go back and say, well, can I recreate it? Can I watch for it again? I need to go, I really want to use Strobe to understand what's going on in it. This removes all that uncertainty. So Mainview's in the position of being able to recognize that you've got a high-consuming job, and in response to that recognition, you can tell it, I want you to contact Strobe. So it does a direct link in context to Strobe, and it says to Strobe, here's the job, here's all the context information. Strobe can perform the data analysis, and now you've got the information to identify why a particular job was impacting your system in such a major way. And I mentioned complexity, and part of complexity is that applications run across all these different subsystems and types of activities. And so Mainview was designed to be able to deal with this effectively. And whether you want to look at the data from a 3270 workstation or from a browser-based GUI, it has that capability. Now, moving into the more autonomic operation, we delivered a capability called intelligent capping. Intelligent capping looks at the caps that you've set, looks at the opportunity to reduce the MSU consumption with capping, but also balances that with which workloads are high priority, and as I make changes to the capping, I also have to be aware of how that might change the MLC costs. It does all of this automatically and dynamically. So this is the easy button for capping. Push the button, it will make adjustments across the various LPARs to allow you to reduce the MLC costs, but mitigate any risk to your critical workloads. I mentioned cost as a major consideration for IT. Mainview has delivered cost efficiency from the beginning, and it's because when you think about monitors, most monitors were designed at a time when we only ran a single image on a mainframe. And as multiple images became available and sysplexes and multiple systems, monitors continued to run one copy of the monitor in each of the image. Mainview recognized that the shift to sysplex and multiple images was a paradigm shift, and they redesigned the way the monitoring did it. So it was designed for sysplex, and that allows it to be very efficient. We use some shared collectors for any place where we're going to collect the same data for two different uses. We say you should collect it once and not have to collect it twice at the overhead. We share address spaces for monitoring and automation and for other functions where possible. We collect the data once and then make it available for multiple different types of users. And we're always looking at ways to optimize the code. And some of those come in some unusual ways. When the Z13 came out, IBM had made some enhancements to some hardware instructions. In the process, some of those hardware instructions caused a little more CPU usage. And we discovered that Mainview used some of those, and in fact, that caused the Mainview overhead to increase. And so seeing that, we changed the Mainview code so we could optimize it, not feel that increase, and deliver the efficiency that our customers expect. We've also been exploiting zips, making our code zip eligible. We were the first ISV to do that. We have comprehensive zip eligibility across not just Mainview, but the data management products as well. And we're always looking for additional ways to improve the performance and reduce the overhead. So just some quick examples. This was a site about 5,500 MIPS. They brought in Mainview. They had another monitor. They compared the overhead of the two. And as you can see, Mainview, if you want a rule of thumb, Mainview will be 30 to 50% less CPU than other monitors. So in their case, that worked out to an MLC savings, just looking at the software MLC savings, of about $150,000 a year. We also deliver a capability called CMF Monitor, which is a replacement for RMF. And so why would someone want to do that? Well, when you run RMF is collecting a lot of data that your ZOS monitor is also collecting. So you're collecting the same data twice. You're paying the tax twice if you're running RMF and any other monitor. It doesn't matter, Mainview or any other monitor. Running with RMF, you're collecting the same data twice. So with CMF, we designed CMF to use the same data collector as Mainview for ZOS. So we collect the data once. Mainview for ZOS can use it for real-time display, alerts, and alarm management. And CMF can record it so that the Type 70 and so on records are recorded and available. So CMF is more efficient, and then when you combine CMF and MainView and the zip offload, we're reducing the amount of overhead that you need to encounter by a substantial amount. Now, modern workloads, I mentioned Java at the beginning. We did some survey questions about Java. This was one of the interesting questions was, where are you using Java on the mainframe? And the answers, across the board, there's not a lot of difference. They're using it or planning to use it everywhere, as native apps within WebSphere, in stored procedures in DB2, under KICS, under IMS, or under the compute grid. It's going to be everywhere. And so what it can look like now or in the near future is you can have Liberty Profile and JVMs sitting in KICS and in IMS, and you get Java and stored procedures, you got a bunch of WAS, and a bunch of batch. Most companies start using Java by looking at their batch first. And all of this is interacting with your existing systems and needs to be managed. The way that Java works, Java behaves totally differently than what we're used to, because it doesn't do memory management. It has a function called garbage collection, maybe appropriately named. And as a result of that, managing the mainframe becomes a little bit more complex. In the survey, when we asked those customers who have Java on the mainframe, what are their biggest challenges, 43% said the performance is a concern. 37% said stability, or the availability that the mainframe is famous for. There's some concern about how to do that. And a third, nearly, said just diagnosing the problem and figuring out, is this a Java problem, is it a COBOL problem, is it a KICS problem, is it a DB2 problem? Where is the problem? That's going to be a problem in itself. So what we've done is we've been working for over the last year on MainView for Java environments. It will actually become GA in the second calendar quarter of this year. It's been in beta since last year. And very quickly, the idea of MainView is to help address those problems that customers see. Number one, you've got to figure out where all those Javas are. So MainView will go out and discover all of the JVMs, discover all of the Java that's out there running, and then monitor the real-time metrics for the Java environment, and allow you to use all of the functionality of MainView, much of what I've talked about, the exception analysis, the alarm management, the ability to integrate across technologies. So within MainView, it's possible to have a single session where I start out looking at the ZOS metrics, and then I may drill from there and link into some DB2 metrics, and I may link into some Java metrics. All of that is seamless. I'm still in MainView, and it's not like I've moved from one product to another. I'm just getting additional data that lets me help drill into the root cause that I'm trying to get to. So integrating Java information with all of the other MainView information and providing that in dashboards and displays that make it clear what's going on and that help solve the problems quickly. Again, this solution will go GA in second quarter calendar year. Think May timeframe, and we'll look forward to reporting on what our beta sites have been accomplishing with it. I've got 3 examples of digital business. Many of you are familiar with travel, so our app is your travel toolkit. There is an investment firm that says you can manage your money from anywhere, even your wrist, and shipping product to merchants. The onboard computers in the trucks keep everything running. Now, what these all have in common is that the mainframe is a core component of what they're all doing. And so if you're sitting there wondering, are we really digital? Are we going to be digital? IBM does the global C-suite study. 9 out of 10 CIOs expect to be digital by 2018. So your CIO is probably headed there. Your infrastructure is going to be digital. The mainframe will probably play a key role in it, and it certainly will be impacted by it. And so as we look at what MainView does, we're positioned to help organizations transform the mainframe to support digital business. And if we go back to the top two priorities, reducing cost and delivering availability, from a survey of 135 MainView customers conducted by TechValidate, 71% said MainView significantly reduced monitoring costs, and 78% said MainView improved the time to detect and diagnose problems. So MainView customers find that MainView delivers on the top two needs of managing IT by reducing cost and delivering availability. So digital business is changing everything, and the question is, will your infrastructure management be ready to handle it? We believe with MainView, you can be there. If you'd like more information, you can visit the MainView page for more information on how to reduce cost on the mainframe, the mainframe cost optimization. And if you'd like more information on the MainView for Java environments solution that will come out soon, you can contact Susan Rice, who is the product manager, or myself. Thank you for being with us. At this point, Janine, we're ready for any questions that you may have.
Okay, Jay, yes, we do have questions coming in. The first one, does MainView have capability to differentiate whether the transactions are coming from mobile browsers or native mobile applications, or is it from regular desktop transactions?
So the short, easy answer is MainView can distinguish transactions and where they're coming from. Now, we won't have time to go into a lot of the detail about how that's done, but if the person asking the question, if you want to send that along, we can provide some more detail to show how we do some of these things.
Which version of MainView and Strobe is needed for integration? Make sense?
That's a good question. For MainView, we delivered a PTF in July of last year, so that MainView supported the Strobe integration, and Strobe delivered a new version in July of last year. And I don't know the Strobe version. I probably should know that. But the PTF from July of 2015 and the Strobe version that was released in July of 2015.
Okay. Does intelligent capping require MainView?
It does not. We mention it as part of MainView because it actually uses some of that highly efficient MainView infrastructure. So it operates very efficiently. You can see what's going on across multiple LPARs, which is the nature of the design of the MainView infrastructure. But it does not require that a customer have MainView to be able to run.
How much data does MainView, self-learning, self-managing, and dynamic thresholds require before it can make recommendations?
That's a really good question. The threshold advisor is actually based on some statistical analysis, and so you have to have a valid number of samples to be able to have confidence in the recommendation that comes out. So think in terms of 28 days as the number that you would like to have, and then, of course, as I mentioned, as time goes on and things change, it wants to continue accumulating observations so that it can make any adjustments that are indicated by those.
Okay. How does CMF save money over RMF?
So there are essentially three ways. CMF uses less CPU, and because those products are running all the time, they're going to be running during peak, and so that's a reduction in the peak usage. And for customers paying for MLC software, that's a savings. CMF also does a substantial amount of zip offload, and any work that's executed on a zip, the zip capacity, the zip usage isn't included in software licensing charges. And then in many customer sites, RMF is an MLC product itself, and if it is, using CMF in place of it eliminates the MLC charge for RMF as well as being more efficient.
So, Jay, is this a redundant question then, or did you just answer it? This is an attendee poses, if the number of transactions are going to increase, then it leads to MIPS consumption, right? Then how do you reduce the MIPS cost?
So if the number of transactions increases, it will lead to MIPS consumption. I'm not sure I understand the question, whether that's a statement about an application or a statement about how does Mainview reduce cost.
Probably the second, because I think what they're saying is, hey, if we're consuming more MIPS, how do we reduce costs of MIPS? And I think it might have to do with what you're saying about peak usage and things like that.
Okay, if the number of, how do we reduce costs? Mainview, if we look at the design of Mainview, the idea of having a common data bus, if you will, and the collectors that collect just the data they need to collect and put it onto the data bus. So whether when the volume of transactions goes up, the overhead is not one-to-one related to the transaction volume. So Mainview reduces cost because a monitor runs all the time, usually. I've heard of customers turning it off during peak period, but not very often. That's when you need it. So the monitor is running during peak, and because Mainview consumes fewer CPU resources than comparable monitors, the amount of MSUs consumed during peak goes down, and the MLC bill goes down. So there's a direct cost savings when the Mainview consumption takes down the peak MSUs.
Okay. Is there any solution to save money optimizing the use of the mainframe storage?
There is. And on one of the slides, it was there in a little box, and I didn't mention it probably as part of it, but there is a Mainview storage resource management set of solutions as well that are part of the Mainview family.
Great. So how difficult is it to switch monitors to Mainview? Forgive me if you've addressed that, but is it tough?
It depends. It's going to be an EPA mileage statement. It depends on the complexity of the environment. Okay, but recently we had 2 instances of customers converting from other monitors to Mainview. It took about 2 weeks. And in one case, the customer said they're not sure they could have done that kind of conversion with any other product. And so it will depend. These were not, they were not 50,000 MIP environments with multiple data centers. So that's why, there's an EPA type of statement, but it is, it's not complex. And as a matter of fact, I think we've replaced monitors we've replaced nearly 50 over the last year or so, 2 years, and customers are finding that it's an easy thing to do to replace, put MainView in and get the benefits that it can deliver.
We have some great questions. I'm going to take time at least for one more, but just know, continue to submit your questions as we speak through the answer on this next one and sign off today, because if we did not get to your question today, someone will reach out to you via email with an answer. Okay, this is MainView for Java. Is there a client code needed on applicable servers for MainView to reach out to JVM?
Yes, there is. So MainView for Java environments has some Java of its own, and we're anticipating covering more detail in MainView for Java actually in another session like this. So watch for information on it.
Great. Unfortunately, that's all we have time for today. I do want to thank everyone for attending today's webinar, and I especially want to thank Jay for sharing his expertise with us today. That concludes our webinar. Do know that we will be sending out a link to a recording of today's webinar early next week. Thanks again, and have a great day.